So in the morning today, I explored the agent communication protocol. Like, what is agent communication protocol? So agent communication protocol is a agent to agent communication or agent interoperability protocol from IBM, right? Similar to what we have from Google, which is A2A, and the other one is Agent C, which is also like developed by Cisco, LangChain, VV8, Clean together, right? So there are three protocols that I know so far, and agent communication protocol is one of them. There is a separate discussion I'll have on the challenges that we might face when we have multiple of this protocol. Probably we need some protocol conversation or protocol conversion mechanism also in future, but that would be a discussion for another day. Today I liked one feature from ACP and I wanted to talk about it, and that feature is this distributed sessions feature, right? This is beautiful because why it is beautiful is, so any agent orchestration, right? Managing the session and the state is very important. Many of the agent frameworks right now does not have a good session management, and I was actually debating whether the session management should be part of the framework itself or it should be abstracted at a higher level, like at the protocol layer level, right? This one looks like the session management has been elevated to the protocol level. The advantage I see, if it is at the protocol level, then and if like we decide to follow a certain protocol, then all the agent frameworks will have a similar session management approach that will improve context sharing or session memory sharing between the agent frameworks. That's why I like it. Um, and that is what I'll show, right? So distributed session is session continuity across multiple server instances. So if I have distributed servers as well, right? So in future, uh, the agent deployment architecture may become, I I will not say may become, it will become decentralized, right? It's the concept of decentralized AI will come in, and um, people will build agents, host on their servers, but uh, agents will need to communicate each other, right? In that case, this distributed session will be of much use, right? So what this distributed session, the core concept is how ACP enables session continuity across independent server instances. ACP enables distributed sessions that can span multiple independent server instances without requiring shared infrastructure. This is achieved through session descriptors in the protocol itself and arbitrary resource servers. You can have a resource server on S3. Right now, I saw that it supports S3, Azure, GCP, local file, and I can do a memory store also, right? The core concept is in distributed sessions, session content is referenced by HTTP URL, and I'll show you how that looks like, right? And stored on an arbitrary resource server, right? It's S3 compatible server. So as I said, like I saw Azure, GCP, and S3. When a session moves between ACP servers, only the session descriptor needs to be forwarded, right? So session descriptor is kind of a URL, right? If I only pass the URL, I don't have to pass a lot of information between server, because in the internet, right, I don't want to pass a lot of information, right? But if I pass the resource descriptor or the session descriptor. With that descriptor, I should be able to get the session details. That's the idea, right? Let's take a look at it once, right? So I took a example that ACP already put into their example storage. It's a Langgraph code, um, not using any LLM, because Langgraph is just an orchestrator, right? It can orchestrate a LLM based agent or any piece of code, right? So here I'm not using any LLM, but because I just wanted to show how that session between the session descriptor works, right? So here I have a node called get time. Get time is the uh, get current hour, right? So get current hour. I'm getting the date time right now. Then I have a decide greeting if it is when we should say good morning, good afternoon, or good evening. And then if I send a name, let's say Rajiv, it should say good morning, Rajiv, or good afternoon, Rajiv. That is a format response. These are the three nodes, right? Get time, decide greeting, format response. None of them are using LLM because we are not this uh, recording is not to show how you can use you can create agents, LLM based agents using LLM using a LangGraph, right? That's why I've not used any LLM here. I just took the example that is there in the SDK, ACP SDK, right? Then I'm setting the entry point as a get time, getting the time. From there, I'm deciding what the greeting is, and then I'm formatting the response. That is the LangGraph code. Now, how do I convert it to ACP compliant protocol? Is where I, after I compile the execution of the workflow logic, I wrap around as a decorator, which is at the server.agent, right? So if you go, it is nothing like but a decorator, and it adds additional metadata to that agent, the agent name, description, agent metadata, and returns the decorator function. That's all, right? It's that's how it is doing it, right? Because once I do it, now I can host it. I can when I say server.run, it will uh, now, so I said server.run port equal to 8000, right? So in my local host now, it will, uh, okay, I think I already used it. So let me use 8001, right? So it will start exposing, it will start exposing its capabilities, its, uh, the agent's services in this portal, right? So if I take this now, right? And if I go to, so let's do the docs, right? So these are the endpoints it is uh, exposing agents, agent name, right? So we can try it out, right? Let's try it out. So if I give an agent name, where do I give the agent name? Okay. Okay. So this is agents, right? List agents, right? So it is actually listing the agent name, LangGraph greeting agent, right? Because that is what I have um, registered, right? This is my LangGraph greeting agent name, right? And when I wrapped it with the uh, decorator, it put the agent name and all, right? So that's why I'm able to see what agents this server has, right? This is this particular um, endpoint, right? Let's look at, so let me close this, and then I have this one, right? Here I can give the name and I should be able to see the details of that agent. Yep, right. So similarly, there are it exposes the run endpoint, run ID, sessions, resource ID. These two will see now, right? Okay, so now my server is running, right? I have, what I did is I made that LangGraph agent ACP compliant, and now I um, in exposing its service through the this endpoint 8001, right? Now I need a client, right? The client to interact with this server, right? So this is the client where I'm saying that with my agent services running here, right? I'm creating a session, right? And this session is that distributed session that I spoke about. Now the beauty is like if I if so LangGraph has a good session management, ADK has a good session management, but if there is a framework which does not have a session management, I can now use the session management of the this protocol. And that is what I was saying. I was debating whether the session management should be part of the framework itself or it should be moved up at the protocol level. This is doing at the protocol level, right? So here I will say enter name, right? I'm interacting with the server now, right? I'm creating the client code and I am doing a session dot run async, right? With the agent name, because this agent name is, I have already exposed. Since I'm already saying where this is exposed, if I give the agent name, it will call this agent, pass this to the LangGraph invoke, and then give me the response, right? So let me run this. And so what I'm doing is I'm also printing the session ID. And I'll tell you why I'm printing the session ID, because I wanted to show you how it stores the history of or the session stores, sto how it does a session storage. So let me run the SCP client, right? So let's say I say Rajiv, and as you know, like it will say good morning or good afternoon. So this is the session variable, right? Now, if I go back here, right? And if I put the session ID now, what you'll see is the session state is now stored, right? This is the history because there are two interactions happened so far. One interaction is where I gave the name and then it responded, good afternoon, Rajiv, right? So if I take this resource ID now, right, and go to my other so endpoint and give the resource ID, this should show me the history of, see, it stored that session state, right? Here I said content Rajiv, right? And the other one, which is, where did it go? Okay, this other one is the response back from the uh, LangGraph code, right? So if I try it out again, now I'll give this, execute this. I should see the good morning part now. Yeah, or good afternoon, Rajiv, right? So this is how the session is getting um, stored as a resource link, right? So history is being right now. If my agents are running on different servers, if um, I can now pass the session state between the agents using this resource descriptors, right? That implementation, I found it very interesting and very useful, and I thought I'll show it how ACP is doing it. I'm still doing some reading on the ACP. As I see it, I like the thought process. I like the thought process. I need to, I'm also planning to now see the difference between A2 and ACP as well. Approach so far I've done some exploration network approach is same. But in future, the challenge will come is what protocol I should use, right? Should I get tied to a protocol? It becomes like REST versus like the gRPC and all those like multiple protocols, right? So there needs to be some type of protocol conversion also, right? If one of my agents is using A2A, but then something is running in ACP, there needs to we need to have a protocol conversion, right? So that is these are the future challenges I see that will come, and then we'll solve for it with new solutions. Right? That's how we have solved so far the previous technology innovations. This also will handle it. Thank you.